Welcome to clickmyproject.com. Now we are going to discuss about the product Discrete Wavelet transform based Whole-Spectral and Sub-Spectral analysis for improved brain tumor clustering using single voxel MR spectroscopy. Now we are going to discuss about the abstract for the process. Image segmentation is the process of partitioning a digital image into multiple segments. A goal of segmentation is to simplify and change the representation of the image into something that is more meaningful and easier to analyze. Edge is one of the prime features of image. It helps us to analyze info and take decisions in various image processing applications. This system proposes a supervised variational level set segmentation method in this project. In this paper proposed a automatic segmentation of tumor regions from the MRI image and enhance the segmentation by and the feature is extracted by using the patterns. Then we have to classify the image by using the KNN classifiers to utilize that the normal or abnormal. Hence this process is more reliable and efficient by using the efficient feature extraction and classification method. Though we have using the several type of segmentation like clustering by using the SOM clustering and then the threshold segmentation, then the watershed segmentation. Now we are going to discuss about the flow diagram for the process. At first the input image is taken from the dataset. The dataset is the folder which consists of the several input images. After getting the input image from the dataset, the pre-processing is carried out. In this pre-processing step, the noise removal and the resize is carried out. In this noise removal is nothing but the removal of noise from the image. After the removal of noise from the image, the enhanced image comes out from the pre-processing steps. Then the thresholding is taken to extract the one threshold value from the image. Then the skull removal is applied to extract the skull regions. Here the image is converted into the binary, hence the skull region is eliminated. The ones regions represents the brain region and the zeros region represents the other background regions. After the skull stripping, the segmentation is carried out. In this segmentation part, the tumor is segmented, that is the tumor extraction will be carried out and the other backgrounds will be eliminated. After the tumor extraction, the feature extraction is carried out by using the patterns and colors. Here the pattern feature is extracted by using the LBP, that is the local binary pattern, and the color feature is extracted by using the histogram. Both the pattern and histogram is extracted. Then we combine the both pattern and color features. After the concatenation of these two features, that is considered as an test feature. After generating the test feature, the classification is carried out. The classification is carried out by using the KNN classification. The KNN classification is abbreviated as an K nearest neighbor. After the classification part, the tumor severity is displayed in the message box and then the analysis is carried out. In this analysis, the performance measures is estimated by using the graph and accuracy of the process is also estimated. These values are plotted in the graph format. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. If you want to execute the code means just right click in the main file.m file and select the option run. Now you can see the folder datasets. Now open the folder dataset and select any one image from the dataset. After the selection of the image from the dataset, the process will be done automatically. Hence, we have the modules like input, pre-processing, skull stripping, segmentation, feature extraction, and then classification. These modules are progress one by one. Hence, the results will be given. Hence, here in the command window you can ask one question, that is the enter the ground truth value. Here we can give the result as 2, then click the button enter. Now the corresponding ground truth will be loaded as per the input image. Now we can discuss the results one by one. Now figure 1 represents the input image which I have taken from the dataset. Then the figure 2 represents the filtered image by using the Gaussian filter method. Then the binary conversion image is shown in the figure 3. In the binary conversion we have the pixel values as ones and zeros only. The ones regions represents the white regions and the zeros region represents the black regions. Then the figure 5 and the figure 6 represents the elimination of the pixels by using the corresponding threshold values. Now in the figure 7 and the figure 8 represents the skull stripped images. The figure 7 represents the skull stripped binary image and the figure 8 represents the skull stripped grayscale image. Now the skull region is eliminated completely, hence the only brain region is shown in the figure window. Figure 9 represents the skull region. Hence the figure 11 represents the boundary deduction by using the contour segmentation method. Now these figures represents the SOM segmentation method. Hence the brain, CSF, then gray matter, white matter regions are displayed in the figure 13. The ranges are shown and represented in the below. Now the classification result is shown as the classified as brain tumor. Then finally the final classification result shows whether the tumor is severe or not.
Thanks for watching this video.